to welcome everybody here. My name is Sharon Morsing. I'm a member of Casca's Sustainability Society Committee, and we're very pleased to present our first speaker in what might end up being a series of talks about astronomy and sustainability. I'm very happy to welcome Travis Rector here. He's a professor of physics and astronomy at the University of Alaska Anchorage, and he's also the chair of the Sustainability Committee for the American Astronomical Society. Much of his work nowadays is on helping astronomers be better educators and communicators of the causes, consequences, and solutions for climate change. He's also exploring ways we can reduce our carbon footprint while also improving our profession. He's also one of the organizers for Astronomers for Planet Earth, which is a grassroots organization of professional astronomers, educators, and students who are working to help our profession address climate change. And I'll just comment that anyone here in Casca can join Astronomers for Planet Earth. And if you're interested, I'll put a link to that in the chat later on. And then I'll just also comment that part of our motivation for doing this is that many of us teach first year astronomy, myself included, and climate change on planets is definitely part of the curriculum. And I think it's really important that we teach this properly and we use this as a way to help people understand what's happening here on Earth. So I'm going to stop there and I'm going to ask Travis to tell us how astronomers can address climate change. Thanks.
Okay, well, thank you, Sharon and Dennis, for inviting me, and thank you all for coming. So Sharon mentioned, my name is Travis Rector, and I'm a professor at the University of Alaska in Anchorage. I just recently heard Alaska be referred to as Canada's Canada, which I thought was pretty funny. So, so I'll just leave it at that. Okay, so to go ahead and get started, there's three things that I'd like for you to take away from this talk. The first is that astronomy as a profession is contributing to climate change. Astronomy is also being affected by climate change. And the good news is that astronomers can help solve climate change. And one of the things I'd like to convey today is that astronomers are in a very important and powerful position to make a difference. And that's one of the things I'd like to talk about, is how we can do that. Nowadays, with COVID going on and down in my country, that it seems like our country is falling apart politically and otherwise, it can often feel like, well, gee, is this the right time to be talking about climate change? Don't we have other things that we should worry about? And sometimes people feel like, well, gee, you know, we don't want to overwhelm people. Well, the reality is even though we are distracted by COVID and other problems, climate change is still happening, and it's something that needs to be addressed urgently. And a common phrase that you hear nowadays is that there's 12 years left or 10 years left to address climate change. And while this isn't true in the sense that it's not a matter of, is climate change going to happen or is it not? It's not like an asteroid. Is it going to hit the Earth or is it not going to hit the Earth? But what does happen in the next 10 to 12 years is of critical importance if we want to avoid the worst consequences of climate change. So when people ask about, well, can we do anything about climate change? Is it too late? The answer is that climate change is here and we're already feeling the effects of it. But the good news is we still have an opportunity to avoid the worst consequences. And what we do in the next 10 to 12 years is going to decide if that happens. So, excuse me. So one of the things I want to emphasize is the urgency of making this part of your curriculum and the things that we do. So this plot right here shows our carbon emissions over the last few decades, and it also shows where we need to be if we want to keep the temperature increase under 2 degrees Celsius total. And so one of the things that I am working with the AAS and other organizations is setting the goal of meeting the requirements of the Paris Accords to try to keep our temperature increase under 2 degrees. And that is, the two goals there is, one is to cut our emissions in half by 2030, and then to get to basically carbon zero somewhere between 2040 and 2050. And so in all of the planning that we do, we need to think about what are the things we can do to reach these goals. So why astronomers? Why should we be involved in this? Well, one part is that astronomers, of course, we know the science very well. We all know radiative transfer. We've learned it. We use it in the research that we do, and we offer an important perspective. So we've all heard the phrase, there is no planet B, and astronomers are in a position to help people understand that the Earth is it. One of the common misconceptions people have is they see press releases about exoplanets and they hear there's thousands of exoplanets out there, maybe some are habitable. And many people think, well, gee, can't we just move to one of those planets if things get really bad here on Earth? And so the whole concept that there is no planet B, that Earth is it, and we need to keep it habitable is a very important perspective that astronomers can talk about. Now, here in the United States, we reach about 300,000 students in our introductory astronomy classes. And for many of our students, this is the last science class they'll ever take. And so this is really our last opportunity to reach them and help them understand climate change. A third part is that astronomers are highly trusted. Unlike the other branches in science, we tend not to be as controversial. And so one of the ironies is that, at least here in the United States, the least trusted group when it comes to talking about climate change are climate scientists. They're often accused of being in it for the money or having some sort of agenda. And astronomers can't be accused of that. And so it's very important for us to speak out on behalf because of climate change, because our climate scientist cohorts are often compromised in that regard. So we can't be accused of having skin in the game. We can talk freely about the science. And another thing is many climate scientists are, especially here in the United States, are muzzled. They're not allowed to do public outreach and things like that. They're at risk of losing their jobs, especially if they work for government institutions. And so it's important for all of us to speak out, especially those of us who aren't at risk of political repercussions. So one of the things I just think is important to emphasize is just the popularity of astronomy in the public eye. And so we can tap into that to help people understand the importance of the topic. Now, one thing I like to emphasize when it comes to talking about climate change is that every talk about climate change needs to include these three essential elements: causes, consequences, and solutions. We actually do a disservice to the people we're talking to if we just simply tell them about what's happening, what's causing climate change, or the consequences. The first question I almost always get when I talk with people about climate change is, what can we do about it? And if you don't have answers for that, then you can give the impression that there's nothing we can do, and we might as well just give up and forget about it. And so this is a challenging part for many scientists, is that we often feel uncomfortable being advocates for solutions, because that feels like we're now leaving science and moving into advocacy. So one of the things that's important to know is how to be able to talk about solutions in a way that is being an honest advocate. So you don't necessarily have to say, I think we should do this or we should do that, but you can talk about the many different solutions that are out there and the pros and cons of each one, and then give people an opportunity to see how they feel about them. But this is something I encourage for you to do, whether you're teaching a class or talking to the public or even talking with a family member, is having these three elements in place in your conversation. Now, an important thing to know is, who is your audience when you're talking about climate change, whether it be a family member or your class or someone else. It's important to know where your audience is and what they understand. So the first place to start is just simply knowing where they are on the spectrum of how concerned they are about climate change. And so there was a survey done by the Yale Program for Climate Change Communication, where they divided people up in my country into what they call the 6 Americas. And these range from people who are alarmed, that is, they're very aware of the issue of climate change and very concerned, going all the way down the scale to dismissive people who say, you know, climate change is a hoax, I'm not worried about it, there's other problems. And so here's a question for you. Where do you think, which of these 6 categories do you think has the most people? in the United States? You can just put your guess in the chat. Okay, so Jane says cautious, disengaged. Okay, more cautious, disengaged, concerned. Anyone else want to gather a guess? Disengaged, okay. So many of you are saying concerned or disengaged or cautious, so maybe somewhere near the middle. Well, here's the answer. Believe it or not, most Americans are in the alarmed category, and the second largest is the concerned. And so this is something that's important to know, is that the majority of Americans are concerned or highly concerned about climate change. And this is often surprising to people to see, because when you see the news, you often hear about the climate deniers. There's a lot of focus on them. And so one thing that's important to know is that when you're talking to an audience, the most likelihood you're going to be talking to people who are concerned about climate change and really want to know what they can do about it. So we often tend to focus on the doubtful and dismissive as sort of like a Captain Ahab and the Great White Whale. We want to convert someone who doesn't believe in climate change into believing in climate change. But I want you to notice those categories are quite small. And in particular, those categories have not changed much at all. And so what that means is that those are people you're very unlikely to convince, and you're better off focusing on the people who you can convince, and more importantly, the people who are concerned about climate change and really want to know what they can do about it. So again, it gets back to this idea of focusing on solutions. The people in the alarmed, concerned, and cautious category, they're really in a position of wanting to know, well, what can we do? How can we fix the problem? So that's really where the focus needs to be. Now, another thing I like to emphasize, especially when talking with my fellow scientists, is that words have meaning, and these words can have different meaning for us than they do for the public. And so here's an example I'd like to give of really bad climate change messaging. And in this quote, it says, models indicate that if we don't reduce carbon emissions by the year 2100, the global average temperature could increase by as much as 8 degrees Celsius. Well, there's all sorts of problems with this statement from a communication standpoint. I'm not arguing the science, but what I am talking about is if you want people to understand the problem of climate change, there's a lot of issues here. The first off is it talks about the year 2100. Well, I don't plan to be alive then. Maybe I'll get lucky, but most of us are not going to be alive then. And even as much as we like to pretend that we care about our children and grandchildren, the reality is we don't. And we're much more focused on our, do we have a job? Are we going to make our house payment? That sort of thing. Another big part of the problem here is it doesn't talk about any of the consequences. Well, okay, so what if the temperature goes up? There are bumper stickers here in Alaska that say, I, for one, welcome global warming. Being a little warmer actually kind of sounds nice up here. So, the problem is that people don't necessarily understand why the temperature is, going up, why that's necessarily a bad thing. And then finally, another problem here, at least in the United States, is we don't know what Celsius is. We're a proud Fahrenheit people. If the rest of the world is going to use Celsius, by golly, we're going to do just the opposite. And so that number doesn't mean anything to a lot of Americans. And then finally here, I'll just mention the first word, which is models. Well, to us, when we hear what a model is, we think of a computer model. When most Americans hear of a model, this is what they think of. And so they're wondering, well, what do models have to do with this? I don't get it. And so that's, it's just an example of how we need to be careful with the wording that we use. And there's a really great paper by Susan Hassel and Somerville where they talk about a lot of these phrases that scientists use and how they can be misinterpreted for the public. And so a really good example is what's called a positive feedback loop. We use this all the time when we talk about climate change. Well, if something is positive, well, that sounds like it's a good thing, right? And so it's important, instead of using phrases like positive feedback, use phrases that people can understand, like vicious cycle. Everyone knows what a vicious cycle is. And so if you're talking about ice melt and you're talking about the positive feedback loop caused by that, it's much better to talk about it as a vicious cycle. Okay. Another thing that's often a problem in science is we use really confusing graphics. We want to cram as much information as we can into every graphic. And so here's one of my all-time favorite, just terrible graphics as far as conveying the ideas that we want. So this plot combines two concepts. It combines measurements of individual glacier thickness, which is shown as the measurements on top. And then it has a line on the bottom that shows cumulative mean thickness change for all of the glaciers. And so there's a lot to unpack in this plot here. And another part of the problem is the way that it uses color. It shows the glaciers that are actually growing, the 3 glaciers were growing, with red bars, and then all the other glaciers with blue bars. And people normally associate the color red with warm and blue with cold. And so there's a lot to unpack in explaining what this graphic means. And so that's something that we need to keep in mind. This is a graphic that can work very well with our fellow scientists, but it's not one that I use with the public because it's too confusing and too hard, takes too long to explain. Now, the next thing I want to talk about is making it relevant. And this gets back to this issue of just talking about a temperature increase without giving any context. And so when it comes to talking about climate change, I urge you to keep it as local as possible. So one of the big problems with climate change communication is that it is often focused on things that like polar bears or islands in the Caribbean that are at risk of flooding. Well, and unless you live in Alaska or Canada, you probably don't care about polar bears, right? The rest of the world tends to think, oh, well, I don't have polar bears where I live, so it doesn't affect me, right? And so one of the issues is wherever you are, you want to talk about how climate change is impacting or will impact where you live, and keep it as hyper-local as you can, and talk about the things that people care about. And what do people care most about? Well, they care most about their lives and their livelihoods and their culture and identity. And so here in Alaska, for example, I focus heavily on my public communication about climate change on the issue of ocean acidification. And there's 2 reasons for that. One is that everyone knows about global warming, but very few people know about ocean acidification. And so here's an opportunity to convey science that few people know about. The other issue is that ocean acidification is a major problem, is a major threat to Alaska's #1 employer, and that is our fishing industry. So we have a lot of people in the state of Alaska who are concerned, are more likely to be concerned about climate change if they understand how it threatens our livelihoods, the jobs that we have, and the culture. So for example, here in Alaska, the salmon is not only a major food source, it is also a major employer, the fishing industry, and it's a major part of our culture. And so if you say to an Alaskan, imagine life without salmon, now you're talking about something that they care about. And so I urge you to think about what are the things that, how is climate change affecting where you live? And not just in Canada, but where in Canada that you are. And now that you have people's attention, now that they understand why they should care, it's time to talk solutions. And unfortunately, when it comes to talking about solutions, we tend to focus on individual actions. And one of the things that unfortunately happens is people are often sent off to go use a climate calculator or a carbon calculator. And I think these are actually not very useful. I think carbon calculators can be useful for people who are already in the alarmed category. That is, they're already very concerned about climate change and are willing to make personal decisions to reduce their carbon footprint. But for most people who still don't really understand the issue of climate change, if you send them to a carbon calculator and they discover how much carbon they're producing, then they feel bad and they feel like, oh my God, this problem is so big, I don't know what to do. And then they just tune out. And one of the biggest problems with carbon calculators is it makes the problem seem like it's an individual choice issue, where their biggest problem is the choices that we have. I would love to own an electric car. And that is something when my I have a 1997 Honda Civic. And when I bought that car, I said, the next car I'm going to buy is electric. I know it's going to be electric. And here we are 23 years later, and there still aren't many options for electric cars. Yes, I could go buy a Tesla and I could spend $30,000 to $50,000 on it, but that's not a good option for where I live in Alaska because they don't even sell Teslas up here. So it's unfair to put the burden on individuals to make good choices if good choices are not available. And so we need to focus on more institutional-wide solutions so that people can have good choices to make. Now, the good news is there are good choices out there, and particularly in the area of renewable energies, these prices are coming down, and so we're at a point now where renewable energies like wind and solar are actually cheaper than fossil fuels. And so one of the things that we need to be careful of is when we talk about excuse me, solutions for climate change, is it often tends to be portrayed as we need to make sacrifices. You know, we need to use less energy, we need to travel less, we need to keep our houses colder, that sort of thing. But the reality is we can have the energy we want, and we can do it in a way that will not cause climate change. And so one of the examples I really like to give is that of Kodiak Island. I like to feature local solutions, local individuals doing good. We Alaskans are proud of our independent nature. We don't like people from the outside world coming and telling us what to do. And so it really helps to show what Alaskans are doing and how they're finding solutions. So for example, on Kodiak Island here in Alaska, which has a wealth of renewable energy resources, they have been able to transition to 100% renewable energy. And in the process, they've actually reduced their cost of electricity. And not only reduced the cost of electricity, but stabilized the prices, and the local economy has grown. And so it's an example of a win-win scenario. By switching to renewable energies, you've grown the economy, you've reduced energy costs, and, oh, by the way, you've also actually done something about climate change. And the majority of people in Kodiak Island are more interested in the former than in the latter. So it's a way of showing how climate change solutions can be good. And in particular, it helps for people to see individuals and groups they relate to doing solutions that they feel will work for them. Now, another thing I like to emphasize when it comes to the conversation about energy is that it often is portrayed as, you know, changing how we've always done things to doing things in a different way. And people are always naturally reluctant to change. And so this is a plot that I stumbled across that has been unexpectedly effective in my climate communication. And what this shows is how energy in the United States has been generated going back from the origin of our country in 1776 to the public. And what I like to point out in this plot is that we've always changed how we've gotten energy. We first used wood, and then we switched to coal, and then petroleum became dominant. And now natural gas and then eventually renewables are becoming the dominant energy source. And so we've always changed the way we've gotten energy, and each new form of energy that we use was less harmful and cheaper than the one we used before. So coal was better than wood because we were no longer clear-cutting forests, and then petroleum and so on. So each energy source has been better than the previous. And all we're doing now is making that next natural transition in our use of energy. Okay, so now what I'd like to do is talk about our own profession. How can we do things in astronomy to make our profession better? Well, it's important to recognize that climate change is a threat to our profession. Now, the most obvious and immediate threat is forest fires. If you've been following the news, you know that in the last month, Lick Observatory in Northern California and Mount Wilson Observatory near Los Angeles have both come within a mile of being destroyed by forest fires. And of course, we build a lot of our telescopes on mountaintops in heavily wooded areas that are difficult to defend from forest fire. So forest fires are an obvious and immediate threat to our observatories, but there's other ways that climate change is a threat as well. So for example, Faustine Cantaloupe just recently wrote a paper describing how climate change is affecting the temperature and the jet stream over and how that's affecting high resolution imaging. We also have to worry about sites like the Atacama Desert, where for the first time ever, you're seeing it rain. And if we're going to build these $100 million telescopes in locations that we anticipate them to operate for many decades, we need to be mindful of how climate change can affect the viability of those locations. And so it is something that is a threat to our profession. So one of the things that I think is important for astronomers is, is to not only be clear-eyed in how climate change is affecting our profession and the mitigation steps that we can do, but also to lead by example, to show that we are concerned about climate change and to be an example for the rest of the world. When it comes to talking with climate deniers, the number one talking point I get is people say, if Al Gore was really concerned about climate change, why is he still flying around in a private jet? And the implication is that if he really felt like it was a problem, he would be willing to make changes to his personal life. And I think actions speak louder than words, and it's very important for astronomers to say, we're concerned about climate change, and we are willing to make the changes that we need to do to address the problem. So we need to make changes, and changes, excuse me, changes need to be on the scale that's necessary. So, you know, just making AA tote bags is a nice gesture, but it's not on the scale that's important. Okay. So one of the things that's been going on is identifying what are the primary sources of the carbon footprint for climate, for astronomers. And it turns out that there's two primary sources. The first is supercomputing. And this was a surprise to me. I just assumed it would be travel, which is the second one. But supercomputing is a major source. And then the second is travel. Now, when it comes to generating electricity for supercomputing, we're basically beholden to other companies or organizations to provide that electricity for us. We can, you know, ask that we use green energy or make that a priority. But one of the things we can do the most about is travel. And the irony is thanks to COVID, we're all doing that right now anyway. And so in a lot of ways, what's happening right now is an opportunity for us to see and to think about the role that travel plays in our profession and what are the things that we can do to do it differently. Now, I don't know about you, but I really don't miss the travel. I mean, every trip from Alaska, it's sort of like, you know, we're like mini Australia. Every trip we take is a long distance to go anywhere. And so being stuck in a, you know, on a crowded airplane with two guys driving their elbows into your shoulders for many, many hours, and, you know, your knees jammed into your armpits because the seat in front of you is so close, traveling isn't fun. You know, it's fun to go to new places. It's fun to maybe visit a city or a place you've never been before. But the actual process is not only uncomfortable, but it's also disruptive. Any conference that you go to, or I go to, means probably a week from being away from home. And so one of the things that's become apparent from COVID and our virtual conferencing is that there is actually there's a high bar for participation in face-to-face conferences. You need to have the money to go there. You need to have the time. And you need to to do those things, you need to have something to present. And so that prevents a lot of participation. And so through virtual conferencing, we're actually starting to see that there's a lot of things that we can do. So virtual meetings are the most obvious and immediate way that we can reduce our carbon footprint. And I don't know about you guys, but I've already discovered a lot of benefits. The first benefit is that I've been able to attend a lot more conferences. There's conferences that are maybe too far away or too expensive to travel. And maybe the topic is something that I'm sort of interested in, but it's not really the focus of my research, or I don't have funding to justify travel for that. But with a virtual conference, I can participate. So for example, CSIRO in Australia had a meeting last month about the future of meetings. It was a meta conference, a meeting on meetings. And that's not the thing that normally the kind of thing that I would be able to participate in. I'm not going to fly all the way to Australia for this topic. But I was able to get online, make a presentation, and be part of the conversation. So it's an example of a conference that I would not normally have been able to attend. Now, another advantage of virtual meetings is that you can make online talks that are pre-recorded. And so you can watch it when you want, you can watch it again, you can look more close, you can pause it, look more closely at the slides, and you can also stretch it out over a longer period of time. Rather than having us try to cram everything into 3 or 4 days, you can spread it out over maybe 3 or 4 weeks and gives people an opportunity to watch the talks when they want. And then you can have like a live Q&A session where you can have the interaction then. So one of the most important things we're recognizing is that virtual meetings can not only address climate change, they can also reduce the barriers for participation. And for the American Astronomical Society, our largest meeting is about 3,000 people. But that's still only 1/3 of the membership. And so even at our largest meetings, 2/3 of our society are not able to participate. And so one of the things we're working on is what are the things we can do to get more participation, even if it's a level where members can just dial in and watch a plenary talk or that sort of thing. And so one of the real benefits is we're able to reduce these barriers for participation. And this is really important for addressing the issues of diversity and equity. One of the papers that came out in Nature Astronomy where they looked at the carbon footprint for Australian astronomy, they noticed a huge discrepancy between senior astronomers and early career astronomers, that the travel budgets for senior astronomers could be 10 times higher than that for grad students and postdocs. Well, that's not fair. And especially because those early career astronomers are the ones who can benefit the most from participation. And often it's a case where people can't participate until they actually have research to present. Well, think about how valuable it can be for a young student to attend a conference and learn what the presentations are like before they actually have to do it themselves. Now, a common criticism of virtual meetings is the difficulty in meeting collaborators. And so that's not to say that we have figured out all the solutions, but one of the things that's really interesting that I'd like people to think about is think about the collaborators you didn't meet because they couldn't participate. They couldn't come to the conference. And so when we talk about virtual meeting versus face-to-face, we often forget that many people can't come to the face-to-face meeting at all. Now, another thing that's important to think about is that virtual conferencing is in the early stages. We still have a lot to learn. And the analogy that I heard once that I really like is that of television. When television was first created, no one knew how to do a TV show. So what did? They just did radio shows on television because they knew how to do radio shows. And I think that's where we're at with virtual conferencing, is that we are doing the things we normally do face-to-face online. And we're discovering that there's a reason why we do things face-to-face, and we aren't constrained by the same things. And so I think what we're going to see over the next few years, especially with COVID, driving this motivation, driving this discovery right now, is that we can do virtual conferencing in ways that are much more effective than we are now and will be much better. And one thing to keep in mind is that the technology continues to improve. And so things that are unwieldy virtually right now may become much easier in the future. And so I just like to show this graphic that I saw at the end of last year, just showing how much a micro SD memory card increased the capacity at the same price point over 10 years. It increased by 500-fold. And so a lot of the things that may be difficult to do online right now are just going to become commonplace. And there's going to be a lot of things we can't even imagine now, like Dennis's avatar here, that are going to just become standard. And so the profession, the technology is going to change. virtual conferencing is going to change, and it's going to make things a lot easier. So the things that I recommend that we do, so other things that we can do to reduce our carbon footprint are things that we're already doing to some degree. So for example, remote observing, online invited talks and review panels. And another thing that's really important in this whole process is reducing our necessity of travel for professional success. And that's something that I think we don't really appreciate, is how essential travel is for success in astronomy. And the number one concern that I hear from astronomers when we talk about reducing our carbon footprint is people say that they want to reduce their travel, but they simply can't afford to professionally. They have to travel to telescopes, they have to be giving invited talks. These are all things that are required of our profession to be successful. And so if we look at ourselves and say, what are other ways that people can demonstrate success in our profession and be competitive for jobs, then the resistance to a lot of these concerns will be reduced. And so things like the social interactions at conferences and things like that, these are all common concerns that we need to be mindful of when we try to address climate change. But one thing that I'd like to emphasize is that change is scary, but change can also be good. And the example that I like to use is that of remote and Q observing. I'm of an age where I remember when the Gemini observatories were first being built and other telescopes were considering switching over to Q observing. And there was quite a bit of resistance. A lot of astronomers felt like, no, it's very important. You need to be at the telescope. You need to see what the weather is doing. You need to be able to make split-second decisions about what you're going to do. And so there was a lot of resistance to that idea. But then what happened is that as Q observing and remote observing started to be used, people realized, hey, wait a minute, you know, there's a lot of advantages to this. We can do science in ways that we couldn't do before. We could have target of opportunity, rapid response, all these sorts of types of astronomy, you know, responding to gamma ray bursts within 60 seconds of a burst, you know, things that simply aren't possible with classical observing. And so what happens is when it comes to change, people often focus on what it is they're going to lose. And it's not until they see what they're going to gain that people start to be more responsive to these sorts of changes. So one of the things I think is important for us to keep in mind is that as astronomy evolves as a profession, we want to minimize the impacts of change on our profession, and especially on early career and marginalized astronomers. And so one of the things I like to emphasize is that as we make these changes, we need to be mindful of, is this going to reduce the disparity between the haves and have-nots in our professions, or is it going to widen the gap? And so all of the decisions that we're working through right now for the AAS as we look at changes to our conference formats and other things that we do, is it going to increase equity and inclusion? And so for early career astronomers, there's things that we may want to do. So for example, have hands-on observing experiences so people know what a telescope is actually doing when it does what it does. We may also want to have face-to-face meetings that can help develop collaborations and connections, especially amongst marginalized groups in our profession. But one thing that I like to emphasize is that, especially for old fuddy-duddies like myself, we don't necessarily appreciate that online relationships can now be just as important as face-to-face. And I already have, you know, examples of people that I've never met in person, like Joel here, who he and I have been working together for many months, and many of the people for Astronomers Planet Earth, and we're doing good stuff together, even though we haven't necessarily met face-to-face. And so online relationships can now be just as important for the profession as the face-to-face ones that we're accustomed to making at meetings. So one of the things that I'd like to emphasize is we want to collaborate with other professional societies, talk with them with what they're doing, but also just change the culture of astronomy. So in particular, devalue the importance of travel in our profession, but also celebrate the successes of how the new way of doing things, whether it be remote observing or Q observing or virtual conferencing, how we can learn and grow from these experiences to make our profession even more inclusive and fair and most importantly, scientifically productive. Okay, so what are the actions that we can take? And I want to focus on collective actions because, as I said earlier, individual actions are important, but the most important thing about individual actions is how they lead to collective change. So what are things that organizations can and are already doing? Well, the first and most obvious is to determine the footprint of professional activities. And so many organizations like ESO are leading the way in determining the footprint of their professional activities, because until you actually know what your carbon footprint is, it's hard to know what are going to be the most effective things to change. And then once you know your footprint, develop plans to reduce on the necessary timescales. Now, often these plans can involve changes that are outside of the purview of our astronomy, but we can at least be advocates for this. So we can, as professional organizations, can go to energy suppliers and say, we want green energy, and this is what we're willing to pay for it, and that sort of thing. Another thing that's really important is institutionalizing of teaching of climate change. If you're at a university, I urge you to work with your colleagues, work with your department, work with your college and your university to institutionalize the teaching of climate change. One of the things that I like to emphasize is that climate change is not a standalone science topic. It is the science topic that affects everything else. And so one of the things I do at my university is I do a lot of guest lecturing, and in places I would have never guessed that I would. I talk to the economics people. I talk with the School of Business. I guest lectured for an MBA program. And I talked about how climate change is affecting business models. And these are organizations that it's important for us as scientists to reach out to and to try to help. And so one of the things I encourage for all of you to do is talk with your institution. It's your next department meeting or staff meeting. Talk about, hey, how are we going to address climate change? What are the things that we can do to be part of that? And also think about beyond your organization. How can we affect the rest of our institution or university? And so finally, also work to make changes elsewhere. Be advocates within your community, be advocates within your family. There's so many opportunities for astronomers to talk to the public, whether it be through the outreach talks we do, talks at planetariums, even just talking at your local city council meetings. Those are opportunities for you as a scientist to go and say, hey, this is a problem, this is what we need to do to fix it, and I want to be part of the solution. And this is something that scientists are often uncomfortable with. We like to stay in our ivory tower and just think great thoughts and know and understand the problem, but not necessarily be involved in the solution. But this is something where we need to be part of the solution because we know what can happen if it doesn't. So it's an amazing time to be alive and to be a part of our profession, and it's a scary time as well. But one of the things that is encouraging for me is just seeing how many people are concerned about the problem and how many people are taking it seriously. And every day I'm inspired by stories of my fellow astronomers and people outside of our profession who are taking bold steps to be part of the solution, whether it be through things like Extinction Rebellion or even just running for local city council. So if you're interested in doing more, I highly recommend that you join our group. We have a group called Astronomers for Planet Earth, and this is our website where you can join us. And we do a lot of things, but one of the things that we do is provide opportunities for astronomers to get more involved. And so one of the things that I've been working on is we're doing a webinar series where we're inviting speakers from within astronomy and beyond to come and talk about the science of climate change, talk about advocacy and solutions. Because what I found is many astronomers feel like they want to do something, but they don't know where to start. And if you don't know where to start, join us and we can help you get involved. And last, I'll just say, if you have any questions or ideas or things, I'm more than happy to talk with anyone and everyone. So you can reach me at this email address as well. Okay, I know I said a lot. I had a lot to cram in. And so I see that there's been a lot of comments in the chat. So if Sharon, if you want to maybe lead us through any of the questions that we have.
So what I'll do first, let's just thank Travis.
Thank you.
And if people want to ask questions, let's just go ahead. We'll start off with William Wall, who has a question.
Hello, am I coming through clearly?
Yes, I can hear you.
Okay, great. Yeah, I really appreciate your talk. It's very informative and eye-opening, and I really appreciate what you're doing here. It's really important
Thank you.
for all of us. I have a comment and a question. Liked your graph showing how the power use changed in the U.S. over a period of more than 200 years. It makes a very good argument that we've always, people have always changed the way they generate energy. One thing that isn't shown there, though, is that when we were accessing wood, for example, it was more democratic in the sense that everyone had their own wood. And now people are relying heavily on oil, and there are just a few large corporations that are controlling who gets the oil, and they're going to fight for their survival. And when we switch over to wind turbines and solar energy, once we get the equipment, it becomes democratic again. We can generate our own energy. So that's one of the reasons there's a large resistance to that.
Right.
My question is, in your graph, where you showed what was being done wrong in showing and demonstrating something to the public, you mentioned the number of things that were done incorrectly. Do you have some example of how to do that correctly?
Well, yeah. So, again, it really gets down. I think it depends on a variety of factors. So it depends, again, depends on your audience, how much time you have with them, how influential you are, and how realistic it is to make changes. And so I'll just give a very simple example. A couple of years ago, I was driving through southern New Mexico, and I stopped at the gas station, was putting gas in the tank, and it was a hot day. And the woman next to me was pumping gas, and she said, "Boy, it's a scorcher today, isn't it?" And I said, "Yeah, I don't recall it ever being this hot before." And she's like, "Yeah." And that was it. That was our climate change conversation. And, I could have been a scientist. I could have rolled out some statistics and said, statistically, the temperature of southern New Mexico has increased by this much. But I recognized a couple things. I'm just some stranger at a gas pump. She doesn't know me. We're only going to talk for a few sentences. And if I could have just reinforced her awareness that things are getting hotter and in ways that are unusual, then maybe I've been able to nudge her just a little bit. And I think that's something that's important to keep in mind when it comes to climate communication. It's very seldom that you can take someone who's a denier and within 10 or 15 minutes of talking to them, just radically change their mind, say, "By golly, you're right. I've seen the light. I'm going to do things differently now." So I think tapping into, if you know an individual, if you know an audience, if you know their values, then you can make a difference. And so another example I'll give is I have a friend who's a deep libertarian. And if you don't know what libertarians are, they're people who basically believe government has virtually no role in our day-to-day lives. And my friend, I was able to convince him to get solar panels on his house, not because he cares about climate change, but because he hates the utility companies. He hates the very fact that you talk about, that a handful of companies control how he gets his energy and how much he has to pay for it. And so getting a solar panel on his house was a big FU to those companies. And so in convincing him, I knew I have a good relationship with him. We've known each other for decades. I know his politics. And I talked about what he cares about, what his values are, not what my values are. And in that process, I was able to have him engage in positive behavior that align with what he cares about. And so that's what I think is really important is in this communication, is to be respectful and mindful of where people are at and what they want to do. And so like your democracy of energy, that's a huge problem. People are beholden to getting energy from a handful of companies. And there is a lot of resistance from those companies. You can tie into that. In the United States, the fierce independence that we feel, nobody's going to tell us what to do. Well, you can tap into that. That's a value that we have and people care about. And so those are a couple examples I'd give.
You're recommending that we don't use graphs so much.
It depends on the type of graph. So like visuals can be very powerful. And that's one of the things that science education research has shown is that if you show a visual that a counter is counter to what you're trying to tell, people will remember the visual and not what you said. So for example, a very powerful visual that's been useful in climate change communication is that of a pie chart that shows what percentage of professional scientists believe climate change is real and human caused. And that's greater than 97%. So if you show a pie chart that's 90% and then shows a little tiny wedge, that visual can actually be more powerful than just simply saying the number. So graphs and visuals do have power in use, but if they're very complicated and people can't immediately intuit what it is trying to say, if you have to explain it, if you're having to explain the vertical axes and the horizontal axes, it's probably not going to be worth using.
Mike Chen has a question.
Go ahead.
Yeah, so I technically have two questions. I'm going to stick to one for now. So one thing that I've been thinking in terms of it's that the lack of climate action seems to be also very much a systemic issue in the sense that a lot of things could have been done collectively as a society through government regulations as well as incentives. And it felt like a lot of our problem right now is that the voters aren't putting enough pressure on the government to take actions kind of thing. So in your opinion, or basically your understanding, what would be some of the things we could do as, you know, astronomers and advocate to push for that in society?
Yeah, so one of the challenges is that the majority of Americans, and I'm just going to speak about my country, I don't know what the statistics are for Canada, the majority of Americans are concerned about climate change, but very few Americans label it as their top priority. So other issues like immigration, employment, you know, Black Lives Matter, these all tend to rise higher up. And so when it comes to politicians, politicians are influenced by, you know, voters and what they value, but also their donors. And since in the United States, basically it's a free-for-all, you can give as much money as you want to any candidate. And if oil companies are giving you a lot of money, it's going to take a lot of voters to counteract that. And that's a huge problem, is that until the majority of people are saying that climate change is one of their top priorities, and they are voting based upon that priority, then politicians are less likely to listen. So as an example to that, here in Alaska, we have someone running for the US Senate. And right out of the bat, he made climate change a priority. He hit the nail on the head. He said, I know ocean acidification is real. He's a commercial fisherman. He says, I know ocean acidification is real, and it's a threat to our fisheries, and I'm going to make it a priority. And I said, and I wrote him immediately and said, I'm on board. What can I do to help? And I have been volunteering for his campaign ever since. And, you know, that's a level for me where I said, this guy has got it. And not only do I want to help him win, but I also want to reward him for making it a priority. And so since he did that for the last few months, I've been volunteering for his campaign. And I won't stop talking about it either. Because for me, it's an example of rewarding politicians for making it a priority. And that's something that as individuals we can do, but we can also try to do collectively as well.
I do have a follow-up on that, but I think I should give Chris a chance to ask a question first.
Okay.
Thanks, Mike. I'll be short. So I want to also thank you, Travis. That was an excellent talk, and it hit all of the important points, which is not easy. So I want to ask about something that I've encountered locally in Toronto. So if you have an institution that wants to acknowledge and do something about climate change, how do you counter the argument that if the institution has the money, they should just reach net zero emissions by offsetting everything with, you know, gold standard offsets and be done with it there and not reduce the overall emissions of the institution on any interesting timescale like you were talking about?
Yeah, carbon offsets are an interesting issue. And I don't have a strong opinion one way or the other. I recognize they can be valuable. And at the AAS, we do use carbon offsets. We do collect them, and we're going to make that just just one of the hidden costs of our doing business. But carbon offsets also can have the consequence of people feeling like they've done what they need to do and they don't have to worry about it. Some carbon offsets could have a more immediate impact. So for example, if you're collecting money and that money is going in landfills, that can be a more immediate effect than if you're planting trees, where those trees may take many decades before they become an important sink of carbon. So I'm not a huge fan.
And they might catch fire as well. That's the
yes. Where if you burn down all of your carbon offsets, then that's not good. So I'm not a big fan of carbon offsets for that reason. I think in the very short term, there's something that organizations can do, and we are doing that for the AAS. But I tend not to include those. I didn't mention them in the talk because I don't really think of those as long-term solutions to the problem. So I don't know if I've answered your question, but I think for those organizations that are considering carbon offsets, I'd say, if you've got the money, fine, do it, but don't make that part of your long-term plan.
Dennis has a question.
Yes, excellent talk, Travis, and I enjoyed your talk at the Future of Meetings conference as well, which I also listened to. So I have a question about balancing climate change concerns against environmental concerns, and this comes up for me in the use of nuclear power to generate electricity. So it's obviously green, doesn't generate much CO2 other than, of course, for construction and mining of the fuel. But of course, there's environmental concerns about nuclear power. So how do you balance those two? What's your perspective on that?
Yeah, nuclear power is an interesting example of where, one thing that I think is important to emphasize, and I have an entire talk that's devoted to energy sources and the pros and cons of each one. And this gets back to when it comes to talking solutions, there's an interesting book out called The Honest Broker by Roger Pielke, which I highly recommend. And I think he does a really nice job of outlining the role as scientists can play in talking about solutions. And that is to be as honest as you can about the pros and cons of each energy solution. And so if you are talking about petroleum, talk about the pros of it. Why do we use petroleum? Well, it's a very high energy density, it's high density energy source. That's the reality of it. But then talk about the cons, and that's true for wind and solar and nuclear and everything else. Now, I'm far from an expert on the economics of this, but it seems like nuclear just hasn't caught on because it's very expensive. And part of that expense does come from the resistance that it has faced, especially in the United States. We have been averse to nuclear power because of what happened at 3 Mile Island back in the 70s. So nuclear power just does not seem to be economically viable. Now, there are new types of nuclear reactors that may change that. And so that dynamic is always changing. And that's also something I like to emphasize, is what's true today may not be true tomorrow as far as which energy sources are good or bad. My personal opinion is and this is my opinion, is that if you have a nuclear reactor and it's running, keep it running. But as far as the economics of building new nuclear reactors, it just seems you're better off going with wind and solar.
We have a question from Julie.
Yes, hi. I'll be quick because I see we're already at the hour. Thanks a lot for your talk. I have a quick question. I work mostly with K-12 students, and I'm guessing you'd give a lot of talks to those levels as well. Do you change your narrative about climate change when you talk to younger students? I feel like many of them, eco-anxiety, and they're getting stressed, or they think the world's going to explode, as I've mentioned in another talk we've both attended. So I'm kind of curious about how you bring that up.
Yeah, that's a really good point. When it comes to talking with children, I think you need to minimize the causes and consequences and focus mostly on solutions and efficacy. It's easy to scare the heck out of children. My poor daughter, who has to hear about climate change all the time, She's 12 years old, and a couple months ago, she came into our bedroom late at night, and she said she was scared. She was having nightmares about drowning. And I said, well, why are you worried about that? It's like, well, the oceans are rising. It's like, oh, in talking about the oceans rising, I didn't realize that I was, causing this vision of producing a water world where the water's just going to go up and up and up and we're all going to drown. And so, I had to explain to her how much it's going to go up and that we're at a much higher altitude and our house isn't going to flood. But it's so easy to scare children. And so talking about solutions and giving them a sense that they can do something and that we're going to fix this. And so a friend of mine, Jeff Bennett, a fellow astronomer who's really, really good at working with kids, he really focuses on talking about a future that's beautiful. Imagine what life could be like if we had all the energy we wanted and it was clean and we didn't have to worry about pollution or climate change and all this stuff, and really inspire kids to want to create that future. So rather than focusing on the gloom and doom of how bad the future can be, he really is good about focusing on how good the future can be. And so I think for the younger audiences, that's really important. And even with my college kids, we have a green fee board at our university. I met with them last Friday, and this is a college girl. She was nearly in tears just talking about how her friends are debating about having kids. Like, do they want to bring their children into a world that's going to be destroyed? And so you really need to think about how can you motivate people towards positive things rather than having them be scared? Because the most common response to fear is just to curl up in a ball and do nothing. And so be driven by a future with clean energy. And so a lot of my talk is talking about all the energy we can have, how it can be cheaper, it can be safer. And that, I think, helps to motivate people. And the reality is that for the most part, the technology we need is already here. It really is a motivational thing. And so with kids, you need to focus on that, I think.
Thanks a lot.
Thank you so much. Let's everybody thank Travis again.
Thank you.
We will be posting Travis's talk up on a YouTube channel to be decided shortly. Travis, there's some interest in having copies of your slides. Would you be willing to let me have like a PDF or something of your?
Absolutely. Yeah, I'll just make a PowerPoint version or PDF, whatever, and be happy to distribute it.
Okay, I think a PDF probably is good. I think we will be creating a website with resources for Canadian astronomers. And so this would be one of the things that will be on there. Our website's not really quite there yet, but sooner or later.
Yeah. Well, just one last thing I'd like to leave you all with is that, the whole reason why I'm doing this is because, like many of you, I was teaching astronomy, and I just noticed an increasing concern and anxiety amongst my students, and I felt the need to address it. And then I saw fellow astronomers doing something. And so people like David Helfand at Columbia were very inspirational to me. It's like, wow, he's recognized this as a problem. He's stepping out. He's making this a priority. And that was the inspiration for me to make it a priority too. And so I hope all of you will make it a priority, and I hope that you will inspire other astronomers and our youth and our communities to do it as well. So I'm more than happy to help anyone in any way I can. Don't be shy about emailing me. I'm happy to share my slides, anything else, because others have been that kind to help me as well.
Thank you again. That's great.
Okay, thank you all.
Thanks, Travis. Thanks, Sharon.
Thanks, everyone, and have a safe week ahead.
Okay, good. See you later.
Bye, everyone.